Now, corrections to the assignment. The question is, the diagram below is a circle passing through the points A, B, C, and D, such that AC and BD meet at a point E. This is a point E. Inside the circle, if DAC equals 27, DAC equals 27, ABD equals 54, ABD equals 54, and ACB equals 63. So you can see that 63 is not given in the question. But we have ACB. ACB. This is 63. That is why you must first read the question. You don't just go straight to the diagram and start solving. No. You need to read the question. Because like this one now, that 63 is not given in the diagram, but we have it in the question. And please don't use that theorem. We state that angle in a semicircle equals to right angle. There is no, you cannot use that theorem here because there is no center in the diagram. The two lines, AC and BD, the two of them do not pass through the center of the circle. So there is no way you can use that theorem. Now, how are we now going to solve the question? We are first looking for that CAB, angle CAB. Question 1, angle CAB. Where is the angle? CAB. This is the angle we are looking for. But how are we now going to solve the question? Now, we can get this. This is 63, this is also 63. That is what is called same segment. If you clean this one now, if you clean this line, you have that 8. It means that this is 27, this is also 27. In fact, I can use that theorem too. Well, let me use that one. If this one is 27, this is 27. Okay? CAD is equals to CBD. I'm referring to this angle. This angle is equals to this angle. Equals to CBD. And that is equals to what? 27 degrees. And the reason is what? Same segment. The reason is same segment. Now when you have this, 27, you can now put 27 degrees here. Now we are looking for curve. Don't forget that this is one angle. This is one angle, and triangle has 3 angles. Now to get this one, this angle CAB plus angle 63 plus the whole angle here, which is 54 plus 27 plus 27 is equals to what? 180 degrees. Reason, sum of angles in a triangle. Are you with me? Then we now have the CAB plus, what is 63 plus 54 plus 27? What is the sum? 144 degrees equals to 180. So we have CAB equals 180 degrees minus 144, and that is what? 36 degrees. So it means that this angle is 36 degrees. That angle is 36 degrees. Then after getting this angle, please, what is the next question then? What is the next question? The next question is to calculate AEB, AEB, over figure 2. Angle AEB. Now to get this angle AEB will not be the problem. AEB. Look at this. In triangle AEB, we can add up all these 3 angles and equal this to what? 180. So AEB plus, I'm referring to this triangle, in triangle AEB. Let me say in triangle AEB. AEB plus 36 plus 54 is equals to what? 180. The same reason sum of angles in a triangle. Sum of angles in a triangle. Now we have AEB plus 90, addition of these two is 90, equals 180. AEB equals 180 degrees minus 90, and the angle is what? 90 degrees. It's a right angle. Okay? So that is how to do the first one. Then the second question is this. The second question is this. Let me have the diagram on the board. We have this.
Yellow only that. Yellow only.
Now, in this one, in this question, we have in the diagram below PQRS, our point on the circle is center O. Center O. T is a point outside the circle. T is a point outside the circle. Angle STR equals angle MRS, which is 32. This is 32. This is 32. Then QPR equals 47. QPR equals 47. And QMST is a straight line. QMST is a straight line. Find PQM. PQM. 1. PQM. Now we are looking for that angle Q. Angle Q is very easy to get. What is that angle Q?
32.
What is the reason? Same segment. PQM. Or, I don't want to say PQM first. Let me say PQS. PQS and PRS. Are you there now? PQM is the same thing as PQS. Okay? PQS is equal to PRS. PRS, which is equal to 32 degrees. Reason, same segment. Same segments. Okay, so therefore PQS is the same thing as PQM, and that is what? 32 degrees. So 32 degrees is the answer to this one. But the next question is to find out of SRT. SRT. Angle SRT. SRT. Let me first locate that angle. SRT. This is the angle. But I want to use something here. I want to use one theorem here. What is the size of this angle? What is the size of this angle? 47. Okay, what is the reason? Why is it 47? Same segment. So let me now label this as QPR. QPR is equals to QSR. QSR, which is equals to 47. Reason, same segment. Same segment. So if this angle is 47, there is one theorem which states that exterior angle of a triangle is equals to sum of its opposite interior angles. Addition of these two angles now is equals to 47. The reason is this. When you have, look at this. When you have a triangle like this, if this one is known as 120, if this one is known as 70, without working it, addition of these two is 120. So this angle is 50. It means that 50 plus 70 must give you 120. That is what is called exterior angle of a triangle. So in this case now, 47 happens to be the exterior angle. Addition of this and this will give us 47. And that is exterior angle of a triangle. What? Any question? Okay, you are blocking the figure. Maybe SRT plus this 32 is equals to 47. Reason, exterior angle of a triangle. Exterior angle of a triangle. Exterior angle of a triangle. That is, if you don't want to use this method, you can get this one. Angle on a straight line. Angle on a straight line. This, subtract this 47 from 180, to give you this one, then this plus this one, sum of angle in a triangle. But there's no need to use that. Instead of using that, I can just say addition of this is equal to 47 exterior angle of a triangle. Then we now have SRT is equal to 47 minus 32, and that is what? 15 degrees. That is SRT. Is there any question on this? Now, write it down if you miss it, and let us continue with the next theorem. Circle geometry. The topic is still circle geometry. Theorem. The opposite angles of a cyclic quadrilateral are supplementary. Now look at the next theorem. The theorem is the opposite angles of the cyclic quadrilateral are supplementary. Now look at this diagram. This is the diagram. This is the center. Let's have this as this is the cyclic quadrilateral. This is the cyclic quadrilateral. This is the center. Let's label these as A, B, C, D. Now, this is what is called cyclic quadrilateral, because you can see that all the vertices of these quadrilateral are on the circumference of the circle. Then, I have explained that all these theorems depend on angle at center twice angle at circumference. All of them. Now, look at this. Let me just construct here. Join this to the center here and this to this point C. I want to label this as X and label this one as Y. What we are trying to prove here is that addition of X and Y is what? 180. When they are supplementary, addition is 180. When two angles are complementary, addition is what? 90. Now, but we know that this is angle at circumference. Angle at center to this X is here. Are you with me now? So it means that AOC, or let me say reflex AOC, because this one is the reflex angle that is greater than 180 but less than 360. Reflex AOC is equals to 2x. That is x times 2 will give us 2x. Angle at center twice angle at circumference. Okay, this is 2x. Likewise for this one too. I can still have this as obtuse AOC. Obtuse AOC is 2y. Because this is 2y. This is 2x. This is 2y. Reason, the same reason. Angle at center, because this is angle at circumference. Angle at center is 2y. And you all know that the two of them are what? Angle at a point. So 2x plus 2y is equals to 360. Reason, sum of angles at a point. at a point. So we now have factorize. X plus y equals to 360. X plus y equals 360 degree all over 2. X plus y equals 180 degree. That's why some of opposite angles of the cyclic quadrilateral are all supplementary. They are supplementary because addition is what? Is 180. And that is what I've just proved to you there. Now, so the next one, because I want to combine two theorems together. The other one is still on that cyclic quadrilateral. That one too is called cyclic quadrilateral. Let me state that theorem here. Theorem: the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Interior opposite angle. Look at this theorem too. Now let me first have, I can still use that diagram where we have A, B, C, D. A, B, C, D. So, for me now to have exterior angle, this is the exterior angle. This is the exterior angle. What this theorem is telling us is that whatever you have here is equals to this. That is exterior angle of the cyclic quadrilateral is equals to the interior opposite angle. Now, then why is it like that? Let me now prove it. I want to join this to O and join this to C. From this one, you are trying to prove that this angle X is equal to this angle X. Or let me use X, let me use Y. Let me use Y. Abi? Now, I can get this angle from the previous theorem because this one is X. This one is addition of the two is what? Is 180 because opposite angle of the cyclic quadrilateral are supplementary. Let me have this as ABC plus ADC is equal to what? 180. Reason: opposite angles of a cyclic quadrilateral. Cyclic quadrilateral. Abi? Now, and we already know that ABC is X according to my own diagram. X plus ADC is equal to 180 degree. I can leave that. I can leave that equation. Now let me now come to this. ADC plus Y is equal to 180. Reason: sum of angles on the straight line. This is, when you have something like this, if you have an angle here and you have another angle here, maybe X and Y. X plus Y is not equal to 180. That is not what is called sum of angles on the straight line. If you have to have sum of angles on the straight line, if you have this, AB, B plus A plus Y is 180. That is sum of angles on the straight line. But for you now to have X and Y, have Y and say sum of angles on the straight line, no. You can only use, what do we call it? Corresponding angle. If the two lines are parallel. If the two lines are parallel now, X is equal to Y. They are corresponding angle. If something give you X like this, that is alternate angle, then the other one is vertically opposite angle. So you cannot say X and Y equals to 180, sum of angles on the straight line. No, that is not how to use the correct theorem. So from here now, what I'm trying to prove is that X is equals to what? Is equals to 1. So we have ADC is equals to 180. Maybe we should have this as let me make ADC the subject of the formula here. From here, ADC is equals to 180 minus x, and from here too, ADC is equals to 180 minus y. But we have ADC equals to this, ADC equals to this. I can just take, let me say equation 1, equation 2. I can now take what we have here in equation 1, 180 minus x, and what we have in equation 2, 180 minus y. Again, when 180 comes in, it will give us 180 minus 180, and that is 0. Minus 0 equals to minus y, where minus cancel minus s is equals to y. That is exterior angle of the cyclic quadrilateral is equals to the interior opposite angle. So you can see that what I'm still using here is some angle at circumference twice, angle at center twice, angle at circumference. That is what I'll be using to derive some of these theorems. Now let's try one or two questions. Let's try this question. Are you ready? Please be fast with what you are writing. Below, comma. A, capital letter A, B, C, D. A, B, C, D are points on a circle. Are point on a circle such that ABC equals 102 degree. ABC equals 102 degree. First stop. CD, line CD, this is how you're going to write it. Line CD is produced to E. Is produced to E. So that AED equals 47 degree. So that AED equals 47 degree. Equals 47 degree. Full stop. Calculate EAD. Calculate EAD. Calculate EAD. Now this is the diagram. This is the diagram. This is the diagram. Now this is the diagram. What we are looking for in this question is EAD. We are looking for EAD. This is the angle. But I want you to look at this angle. This line here is not a straight line. BAE is not a straight line. You know, it is a straight line now. This is what we are going to have. This is a straight line. This is a straight line. It's a straight line. Are you with me now? But this is not a straight line. BAE is not a straight line. It's not a straight line. So how are we now going to solve this? I can use, it depends on how you can use the theorem. I can get this by subtracting 102 from 180 because the two angles are supplementary. Or I can even ignore that theorem and use exterior angle. As this one is 102, this is 102. That is exterior angles of the cyclic quadrilateral. That is what I put here. This, the exterior angle. This is, you know, this is how to get this thing. When you have exterior, interior to this exterior is this. then which one is opposite to this angle? This is the angle. So these two angles are what? They are equal. So it means that if this one is 102, this is 102. Is that taken out? So I can just skip that first theorem and say ADE is equals to ABC, which is now equals to 102 degree. Reason: exterior angles of a cyclic quadrilateral. Exterior angles of a cyclic quadrilateral. Now, if this one is now 102, to get this one will not be the problem, because we are not talking of what? Triangle. Sum of angle in the triangle is what? 180. So we now have this 47 plus 102 plus A. What are we looking for? Is it EAG, Abi? EAG, which is now equals to 180. Reason: sum of angles in a triangle. Then we now have 149. 149 plus EAG equals to 180. EAG 180 degree minus 149, and that is 41. Is it 41? 21 degree, Abi? That is EAG. EAG is 41 degree. I hope it is clear. Is there any question? There's no question, right? Okay, if there's no question, let me still give you another example of this. Then after that, I will now give you class work to do. PQRS is a circle center O. PQRS is a circle center O. Full stop. If hello, is anything equals to 150 degrees? Comma. POQ equals 150 degrees. Angle QSR equals 40 degrees. And angle SQP equals 45 degrees. Calculate RQS. Calculate RQS. Calculate RQS. Now you draw this diagram. Now this is the diagram. Now look at this question. But you have to be careful here. This 45 degree is not for only OQP. This 45 is for SQP. Because that is why if you take this angle as 45, and you know, okay, this is radius, base angle of isosceles triangles are equal. 45 plus 150 is more than 180, and it is not possible. Are you with me now? So what I will now do is this. The first question is to, okay, we are looking for RQS. RQS. This is the angle we are looking for. I can get this angle. You know, this is angle at center, while this one is angle at circumference. Abi? So to get this PSQ is equals to 150 degree all over 2. Reason, angle at center twice angle at circumference. So we have this as 75 degree. So this angle is 75. After getting this angle, we can add up the two. So that the thing will now give us 115 degree. So if this angle is 115, please don't forget that PSR and PQR, they are supplementary. They are supplementary. Are you with me? Okay, it's like we have, let me clean this line for you to see what I'm talking about. Look at this. This angle 115 is chasing this angle. Addition of these two, forget about this 45 that we have here. Addition of these two angles is what? Is 180. From the previous theorem, we stated that opposite angles of the cyclic quadrilateral are supplementary. So this is 115 plus this one will give us 180. So let me take this as PQR plus 115 is equals to 180. Reason, opposite angles of a cyclic quadrilateral. So we now have this as PQR 180 minus 115. And that is what? What is the difference? 65 degrees. If the whole angle here is 65, from here to here is 45. And we are looking for this angle. We are looking for, that I can form another equation here. 45 plus SQR, which is the or RQS. SQR, RQS are the same. RQS is equal to 65. There is no reason here because addition of these two angles is equal to what? 65. Then RQS, the question that we are looking for, equal minus 45, and that is what? 20. Is 20 degrees. That is how to solve the question. In the diagram below, ABCD is a cyclic quadrilateral. If DAX 40 degree and ASD 60 degree, calculate ABC. Calculate ABC. Now this is the diagram. Now this is the question. Oh, sorry, this is 40. That's the question. What is the size of that ABC? What is the size of that ABC? Folani, do you want to try? Oh yeah, come and solve it for us. Oh yeah, Folani, come. I will be calling you now. I will still come back to you. Yeah. Okay, that point is D. Oh, I did not put it there. Oh, yeah. Okay, ADS is 80. Now, is this the final answer? No. No. Okay, go and sit down. Now you miss it from here. Because after getting this as 80, these two angles are not equal. They are what? They are supplementary. Addition of these two angles is what? Is that taken? Not that they are equal. So that is where you miss it. Now who can continue from there? No, not you. BGC. We have to come and solve it for us. BGC, no. Continue from here. I know, you can use the other side. Now, which theorem is this? Which theorem did you use then? ABC is equals to, you said ABC plus 60 plus 80 equals 180. Now, when you have ABC plus 60 plus this one equals 180, is that the triangle again? Bring the marker. Oh yeah, Ashero, that girl. Is that the final answer? Yes. Please clap for her. Once you have these as 80, the two angles, they are supplementary. Addition of these two is what? 180. So what you need to do is to subtract 80 from 180 and get what? 100. Is that taken? Aha. So I'm going to give you another one now. So I want the board to solve this question for us. Are you ready? Are you ready? Now, right, in the diagram below, this is another question. In the diagram below, comma, calculate the value of x. In the diagram below, comma, calculate the value of x, giving a reason for each step in your answer. Giving a reason for each step in your answer. Now this is the diagram. Now this is the diagram. Let me give you a few minutes to solve this. Then I want the board to come and solve it for us. 180 minus 60. That's equals to 120. Okay. So S is now equals to 60. Okay, thank you. Is that the answer? Yes, Yvonne. Oh yeah, that boy from Abel. Let me gain this 120 and 60 that we have.
I know. I'll use it every time.
That's the best method. Is that the answer? Yes, sir. Please clap for it. Now, I expect you, the student that solved this one, I expect you to use this theorem. Once you have this is 2x, this is 2x too. Exterior angle of the cyclic quadrilateral. And once you get this as 2x, 2f plus f plus 60 equals to 180. Sum of angle in a triangle, that's all. Instead of using, or even if you first get this one as 120, you get this one as 60. You can get this one as 180 minus 2x. And now add everything together and you equate this to 360, you still get it. But it's wasting of time. Is that taken? So you can use it, but you don't get it. You don't get that result. I hope it is clear. Okay, now. What do I do? When you write it. The circle. O is the center of the circle. Comma. Comma. Angle OQR equals 32 and angle TPQ equals 15. Calculate 1. Angle QPR 2. Angle TQO. Now let me draw the diagram of the board. Now this is the diagram. Now this is the diagram. Now I will explain this. I will now give you another one. Are you ready? Now this is my question. We are looking for QPR. Where is the angle? QPR. This is the angle. The angle is very simple to calculate. What's the name of this line? OQ? OR? What type of triangle is that? Isosceles. And the two base angles are equal. OQR. OQR is equal to ORQ. ORQ. And that is 32 degrees. The whole angle, it is not this one that is 32, it is this. The angle stops here. So this is 32 degrees. So if that angle is 32, we can get this angle O by using sum of angles in a triangle. 32 plus 32 plus QOR is equals to 180 degrees. Reason, sum of angles in a triangle. 64. 32 plus 32, 64. QOR 180. QOR 180 degree minus 64. 116. This angle is 116. You cannot get this. No, we cannot get this QPR that we are looking for now by dividing this one by 2. Angle at center twice, angle at circumference. So QPR is now equal to 116 degree all over 2. Reason, angle at center twice angle at circumference. So that's 58. That's the first question, 58. Then TQO. Tony, go and solve that QTO for us. So you are the one laughing there. QTO. TQO is TQO now. TQO. TQO. And now that's the question now. That's the question. TQO. my marker. Now look at this. If you want to get that TQO, listen. You must know that this is PTQR is a cyclic quadrilateral. And once you have these as 73, opposite to this one too. The whole angle here is 107. And once you subtract 32 from 107, the remaining one is TQ. Is that taken? That is that. I also have another one. (15 plus 58, which is equal to 70. Don't just write 15 plus 50. What is that? (80°) and SRT equals 20°. First stop. What size is size? S-I-Z-E. What size is PXR? What size is PSR? What size is PSR? Now this is the diagram. This is the diagram. Now this is the question. Now I want a girl to come and solve this one for us. When you are through, let us. Is that the answer?
Yes.
Clap for her. But there's something I want to correct here. XSR. XSR. Then plus this one. You will discover that when you take this as a point, this and this one, that's not exactly quadrilateral. Why can't you take this? PSR. Is that taken? So let's change this one to PSR. And from here, once you get this as 20, 120, instead of saying you want to get this angle again, why can't you use exterior angle of the triangle? Addition of these two will give you this. Instead of first getting some of angle in a triangle and later use some of angle in a straight, you are wasting your time. So addition of this is equal to this. That is exterior angle of the triangle. Is that taken? Is that clear? Okay? I also have another one. Find the We have these three diagrams. We have these three diagrams. The first one, we are looking for the marked angle. We are looking for the marked angle. We are looking for the marked angle. X, okay? Go at center twice and go at circumference. Okay. That's 58. Okay. So one was at the points, okay? That's I think it's 244. 244, right? 244. What is green?
So we need to get y.
Okay.
Y minus
Addition.
yes. 58 b plus 244 b plus 25.
Okay. Okay, yeah, please help me to calculate this. 360 minus 58 plus 244 plus 25. Is that the answer? Yes. Okay, please clap for him. But this is one method. You can also use this method. You can use this method. Is 116 over 2. The same reason, 58. Angle at center twice angle at circumference. So if this one is 58, I will divide. I will construct so that this one will give us radius. As this one is 25, this is 25. Okay, as this one is y, according to him there, this is also y. Are you with me? So, for me now to get y is now equals to x minus 25. And what is x? 58 minus 25. And that's 33. It's the same thing. Because what I use here is based on what I said triangles. Okay, we can solve the second question. I can't hear laughing. Precious, do you want to try the second one? Do you want to try? Yeah. If you want to try, come and solve it for us. Or you are still thinking of how to. Who can solve it? Number 2. Bring it. Once you divide that 62 by 2, you are wrong. Because that's not the bisector. That line is not the bisector. Oh yeah. That line is not the bisector. That 31 that we have there. Okay. Okay, you want to clean it like 62. Oh, hello. Clean this. Clean the workings of this one. Oh, you are not writing this. Why goes that three? And clean it now so that you'll be able to see clearly. Take the duster there and let them see the solution. Is that the answer? I don't know the answer, but let's look at the question. Where's the duster? Okay, okay, we have ABC. Okay, I can label A, B, C, D. I can get this angle. That is opposite angles of a cyclic collateral. BCD plus 62 is equals to 180. Opposite angles of the cyclic quadrilateral. Cyclic quad. This is a cyclic collateral, ABCD. Oh, don't you know that? ABCD is a cyclic collateral. See? Now, BCD, 180 minus 62. What do we have? 118. This is 90. ACD is equal to 90 degrees. Reason, angle in a semicircle. Abi?
Yes, sir.
So if this angle is 90 and the whole angle is 118, Abi, this one is 28. Abi,
Yes, sir.
subtract 90 from 118, 28.
28.
BCA or ACB is equals to BAC, and that is 28 too. Reason, base angles of isosceles triangle. So this is also 28. Therefore this ABC now plus 28 plus 28 is equals to 180. Sum of angles in the triangle. ABC plus 56 is equals to 180. ABC 180 minus 56, that's 124. 124 is the answer. It's wrong. Because you have taken it as parallelogram. You know that when you have, it is only when you have a rhombus. Rhombus is a parallelogram, but kite is not a parallelogram. This thing is more or less kite. It's kite. You know that? So it's wrong. The solution is wrong. So that's how to go about that. It remains the last one. Do you want to solve the last question for us? That boy from Baptist, do you have any idea? Please feel free to chip in your own idea now. Nobody is perfect as far as mathematics is concerned. Nobody is perfect. If you have any idea, you can bring it to the class. Let us gain from it. Please keep quiet. Okay, anybody? Oh, you want to try? Yeah, come. You can use the other side. Come on, come on, sit down somewhere. Okay. Stay. Keep quiet. Stay. Keep quiet. You want to? Let it finish. Hey boy, what are you constructing? You want to try it too? Okay, you two want to try. Here, come. Use the other side there.
Precious.
Clean that side. Again, that's the last one. Want to draw the diagram there? Hello, hello. Everybody sit down. Okay. Hello, everyone, please. Answer your sister. I'll solve it for you.
No, I don't know my sister.
The question is inside that new German mathematics.
It's there, but it's
Hello, now listen.
Yes. Hello. Now, what are we not solving? Because when you
have minus 2l plus 2s, it will give you 0, and there's no variable again in the solution. Bring the marker. Bring it, please. Thank you. This is radius, and if these two lines are parallel, you know that if these two lines are parallel, and this side is equal to this length, then it means it's what? It's a rhombus. So if this one is x, this is 2x. Angle as center twice angle as circumference. Have you? You know that? This is also x. That is opposite sides of a, rhombus. They are equal. So we now have this. 2x plus x equals to 360. Sum of angles at a point. Sum of angles at a point. So 3x equals to 360. X equals to 360 over 3. And that's 120. So if x is 120, 120, 120. Call this one y and call this one y2. They are equal. 2y and y plus 120 plus 120 equals to 360. Sum of angles in a quadrilateral. Sum of angles in a quadrilateral. 2y plus 240 equals to 360. 2y equals to 360 minus 240. 2y equals to 120. Y equals to 120 over 2. Y equals to 60. Y is 60 degrees. Go and check that as well. You see it there. Yeah, I know there's no solution, but that is how to solve it. Okay, yeah. So you have the textbook with you. You are tired, Ken? We've not finished it. When it is 5:30, I will stop. I'm tired as well. But let's stop at 5:30. You can say supplementary is very interesting. You must always think. In the diagram, PQRS is a circle. PQRS is a circle. PQRS is a circle with center O and radius 7 centimeter. With center O and radius 7 centimeter. Full stop. SQ and PR intersect at K. SQ and PR intersect at K, and angle SKR. Angle SKR equals 90 degrees. If the length of the arc, SR, is 4 times that of arc PQ, find the length of arc SR. Find the length of arc SR. Open the bracket. Full stop. Open the bracket. Take pi equals 22 over 7. Take pi equals 22 over 7. Now let me now draw the diagram. This is GC question 2. No, is it GC or YX question? It's YX. The line does not pass through the center. We are looking to find the length of arc SR. Okay, this is S. SR. Let me pass it to you. Now, I have to construct here. I have to construct. PQ. SR. So, according to there's one statement in the question which states that the length, please read that question 4 times. Okay, this one, PQ. This SR is 4 times that of this one, Abi. Abi, what's the statement again? Read.
SR is 4 times that of...
Okay, SR is 4 times that of PQ. PQ is theta. Let me use theta here as angle. Why this one is 4 theta? Is that taken? Is that clear? Now, there is something again here. There is something again here. I can get, what is it?
Sir, it's length of arc now.
Length of arc.
Yeah, if the length of
You know, the angle determined is proportional to the length. The angle is proportional to the length. Are you with me now? If the angle is 30 and the angle is 60, you know, it is the angle that determines what will be the length of the arc. It's proportional. Are you with me now? So this one that is 4 theta, look at this. This one that is 4 theta, this is 2 theta. Do you know that?
yes, sir.
Angle at center, let me say SPR is equals to 4 theta all over 2. Reason, angle at center twice angle at circumference. So this is 2 theta. That's why this one is 2 theta. Then there is something again here. There is something again here. You know, you can see, please listen. I want to clean this line for you to see that 8. Clean this line. Or let me have this line back. And clean this one. I will still draw it back. Can you see that 8? Or let me clean this. Can you see this 8? This 8. This angle at center. This angle at circumference. This theta over 2. You know that? This is theta. This is theta over 2. You know, I gave you 3 conditions for that angle at center twice angle at circumference. The third one is this. Here you have this. And I said this angle is angle at circumference. Times 2 of this will give you this. So if this angle at center here is theta, this one is theta over 2. Am I communicating?
Yes, sir.
So this one is, okay, let me now have the diagram back. PSQ. PSQ is equals to theta over 2. Reason, angle at center, the same reason. Angle at center twice angle at circumference. So this is theta over 2. Please don't also forget that this is 90 degrees too. That's the right angle triangle. Sum of angle in a triangle. Theta over 2 plus 2 theta. Theta over 2 plus 2 theta plus 90 is equals to 180 degrees. Sum of angle in a triangle, Abi? Okay. So this one is, SCM is, let's say you have 2 theta plus 4 theta, right? Is equals to 180 minus 90. 5 theta, right? Over 2. Is equals to what? 90. 5 theta equals to 90 times 2. 5 theta equals to 180. 180 over 5 is what? 36. If theta is 36, theta is 36. Don't forget that we are looking for length of an arc of SR. I can get this theta now. This angle. That is 4 times. 4 theta is now 4 times 36, and that is what? 144. Length of arc. length of arc SR. Theta over 360. No, don't let me say theta. The formula is theta over 3 times 2 pi r, Abi. But my theta is 144, not this theta. Okay, maybe let me change it to beta over 360 times 2 pi r. So that if I use theta, it will look as if my theta is 36. So that's why I change the formula to beta over 360. So this is 144 over 360 times 2 times 22 over 7 times 7. And the radius is 7, right? 7 cancels 7. 144 times 44 all over 360. What do we have? 17.6 centimeter. Is that the answer?
Yes, sir.
It's to carry. It's just that I've been doing it over and over 24 years now.
Experience.
On circle geometry too. It's like you want to draw us back. On circle geometry. On which topic now?
No, it's really a topic. Teacher give us like class of assignments.
Class what? No. If it is, we have 3, 4, 5. Why this one is R? Okay, I asked you to calculate R, Abi. Let me pass it to you. Okay. Let's look at this. But there is one thing about this theorem. We need to use what is called tangent from an external point are equal. No, there is one theorem. When you have this is a circle, this is a tangent, this is also a tangent. The two lengths are equal. Why? This is, there's another theorem which says that radius is perpendicular to the tangent. Radius is perpendicular to the tangent. This line is common to the two. Right angle, right angle. If there is one angle here, and this line is a bisector. This line here is a bisector. If this line bisects this angle, it means that, and this one is 90. This triangle is a replica of this one. That's why the two lengths here are equal. Now, what I will now use here is this. Let me come here and write. This is also R. This is R2. This is R. From here to here is R. So this one, from here to here, is 4 minus R. Do you know that?
No.
R. The full length is R, that is 4. From here to here is R. From here to here is R, which is equal to this. So if the full length is 4, and from here to here is R, the remaining one is 4 minus R. Are you with me?
Yes, sir.
This is a tangent. This is also a tangent. This is 4 minus R, this is also 4 minus R. From here to here. They are equal. That's what I explained there. Okay? I will still come to this one. This is R2. This one from here. From here to here is 3 minus R. 3 minus R. Abi?
Yes, sir.
Which is equals to this. 3 minus R. Abi?
Yes, sir.
So addition of 3 minus R and 4 minus R equals to 5. Minus 2R plus 7 is equals to 5. Minus 2R equals to 5 minus 7. Minus 2R equals to minus 2. Minus 1, so R is 1. 1 centimeter. It's 1 centimeter. I'll take a question with you. Is that taking? Yes. On the triangle. okay, you want to find area of what?
Radius of the inscribed circle.
Radius. Okay, you have this. You have this. Let's say this is a circle. You now have this. Okay, you have this as triangle. You now want to find the radius. You now use area of a triangle minus. Okay, which one? Inscribe, not okay. Circumscribe. Okay, inscribe. Okay, you now use area of triangle all over. How did you arrive at that formula, please? Online. Try to get out to arrive at that formula. Area of triangle all over. Or then after using that formula, did you get the radius? It's possible. It is possible. In the diagram below, comma, O is the center of circle. O is the center of circle. A, B, C, D, E. A, B, C, D, E. Comma. DC is equals to DE, comma, COB equals to 44, and ABE equals to 59. Calculate the sizes of the angles of pentagon A, B, C, D, E. Now let me draw the diagram for you. A, B, C, D, E. 144, 44, 59. That's all. Number one. This is number one question. Number two. That is one of the assignments. Number two. Are you ready? Number two. In the diagram below, comma, the two circles. In the diagram below, comma, the two circles intersect at X and Y. The two circles intersect at X and Y. Full stop. The center of the smaller circle, is on the circumference of the bigger circle. The center of the smaller circle is on the circumference of the bigger circle. Full stop. A and B, capital letter A and B are any 2 points on the major axis. A and B are any 2 points on the major axis. Full stop. Comma. One on each circle. A and B are any 2 points on the major axis, comma. One on each circle. Full stop. Find an equation connecting A and B. Find an equation connecting A and B. Find an equation connecting small letter A and B. Small letter A and B now. This is the diagram. So take these two as assignments. Hello, who is going to keep this man? What?